We are finding the determinant of question number 16 on section 6.6, which technically, if we're finding the determinant, then we would notate that by making sure we just use the lines that look like absolute values instead of the brackets.
Okay.
I don't know if that's the way it's written in the book, but that's what that means. So when they're just straight lines, that literally means find the determinant.
Okay.
Instead of, if the brackets are there, it's just saying, here's a matrix, here's all your data. But if the lines are there, it's saying, you've got to calculate the determinant to do this problem, or something like that. So, I don't know. It's just a mathematical way of indicating what you're doing. Kind of like the plus sign tells us to add. And, you know, symbols. Math is all about symbols. Okay, so first thing we do is we take column 1. I'm going to use, do you care if I use my little diagonal method, or would you rather I did the cofactor method? Do you know what I'm talking about? You want me to just choose one and go with it? There's two ways to do 3 by 3 determinants. You can either do where you choose a row or a column and then you do the determinants of the leftovers in a pattern. You have to remember whether it's positive or negative in that particular spot. Or the way I prefer is where I just copy column 1, copy column 2, and then just multiply the diagonals. Is it okay if I do it this way?
Yeah.
Okay, perfect. So I rewrote column 1, I rewrote column 2, so it's like wrapped around, sort of. That's the idea behind it, is we're wrapping it. So then we take 1 times 3 times 19. It wasn't 19, correct?
Yeah.
Okay, and let's compute that. So 3 times 19, okay, 38 plus 19, 457? I hope. Perfect. Awesome. So then I'm going to do 2 times 11 times 3. So that's 22 times 3. That should be 66. And then we're going to do 3 times 2 times 4. So 3 times 2, which is 6, times 4, which is 24. So those numbers all get added together. I usually do that separately. Am I going too fast, Carlos? Are we good?
Yeah, we're good.
Okay, then I go the other direction, and these get to be subtracted, right? So 3 times 3 times 3. I never give myself enough space. So 3 times 3 times 3 is 27. Now these numbers are all subtracted from these numbers, but what I like to do is find this sum, and then find this sum, and then subtract this sum from that sum. I just find that easiest. You can really do whatever. Okay, another color, like out of colors. Let's see, let's do 4 times 11 times 1. 1 doesn't change anything, so 44. And I'll just go back to red. 19 times 2 times 2. Thank you. Saving time. Okay, we're going to add these together. Do you want to add them for me? Okay, 7 plus 6 is 13. So 123 plus 24, 147. Oh, it's another 147, isn't it? Excuse me. So the determinant is 0. And what that means is if you were actually using, like if this was a 2 by 2 and you got that determinant of 0 and you tried using it to find an inverse, you wouldn't be able to find an inverse because you do 1 over the determinant and then you end up dividing by 0. So I'm not sure if this problem is solvable. That's not the question here. The question is, what's the determinant? So we accomplished that. Finding a 3 by